Prime numbers have fascinated mathematicians for millennia, and there are entire branches of number theory that deal with primes. Now luckily you only need to know the basics, and the chances are you probably already do. So let's just do a quick review and look at how the test might have you apply these concepts. Prime numbers are integers greater than 1, so these are integers, entire numbers, that have no factors other than 1 in the number itself. So for example, 5 is a prime number because the only factors of 5 are 5 and 1. 7 is a prime number because the only factors of 7 are 7 and 1. 6 is not a prime number because it has factors other than 1 and 6, such as 2 and 3. In fact, 6 is an example of a composite number, meaning it has factors other than 1 and itself. Now in this list of composite numbers, you'll notice that all the even numbers greater than 2 are composites, like 4, 6, 8, 10, 12, 14, 16. And you may ask yourself, well, why is that? Why are all even numbers greater than 2 composites? Well, it's because they will always have a factor of 2. For example, 10 is a composite number because it can be written as 2 times 5. 12 can be written as 2 times 6. 14 can be written as 2 times 7, so on and so forth. One thing you may be asked to do on the test is to perform operations with the prime factors of a composite number. For example, a test question may ask you to find the sum of the two largest prime factors of 12. To solve this, we need to first find all the prime factors of 12. Now, one common way of doing this is to use a factor tree. In making factor trees, we start by writing any two factors of the composite number beneath it. Now, I chose 2 because 2 is the smallest prime, and I like to work my way up through the primes when testing for prime factorization. 2 times 6 is 12. 2 is a prime number, so what I'm going to do is circle it right away since it's going to be one of my prime factors. Now we're done with 2, so we need to write the factors of 6. Well, again, starting with 2, 2 goes into 6 3 times, and I see that both 2 and 3 are prime factors, so I'm going to go ahead and circle them. So the prime factors of 12 are 2, 2, and 3 because 2 times 2 times 3 is 12. Now I could have started with 3 and 4 and ended up with the same result. 3 is prime, so it gets circled, and 4 can be broken up into 2 times 2, which are prime numbers. So now we go back to the original problem, which was to find the sum of the two largest prime factors of 12. Well, the two largest prime factors are 2 and 3. So sum means add, so 2 plus 3 is 5, which would be your answer. So I want you to try one on your own now. Now in this problem, 693 is a much bigger number than 12, but the way you approach it's going to be the same. So I'll give you a hint. Using your calculator, start by dividing the number by the smallest prime and work up. The first prime is 2, but we know that's not going to go into 693 because 693 is not an even number. The next prime is 3, so try that. Alright, go ahead and pause the video now. Okay, welcome back. Hopefully you had a chance to go through this. Now the smallest and largest prime factors of 693 are 3 and 11 respectively. Since the question asks for the product of these numbers, we need to multiply 3 and 11 to get 33. Let's review how we got that answer. As I recommended before, when you have a larger number, start by checking whether the smaller primes like 2, 3, 5, and 7 are factors. 2 clearly isn't, but 3 goes into 693 231 times. Now 3 is a prime factor, so I circle it, and now I start the process over with 231. Again, 2 is not going to go into 231 since it's odd, so I again start with 3. 3 goes into 231 77 times. Now, 77 is a composite number. I check 2, it doesn't go in, 3, 5, they don't go in, and the next prime is 7. 7 goes into 77 11 times, and 7 and 11 are both primes, so I've now factor this down to its primes. We've got 3, 3, 7, and 11. Finally, I'm going to multiply the largest and smallest primes, which are easy to spot since I've circled the prime numbers. So the smallest one is 3, the largest prime factor is 11. 3 times 11 is 33.